This problem asks us to find the antiderivative of the natural log of x squared. We're going to do an approach called integration by parts in order to manage this. The first thing that we can do is to rewrite this equation to be the natural log of x times the natural log of x. We do this because this integration by parts technique can be done whenever two functions are being multiplied together. And now it's a little easier to see that it is. In general, whenever we have a formula that starts out as the integral of a quantity u times another function that we call dv, it'll simplify to being u times v minus the integral of v times du. We'll get to more on the v in just a minute. For now, let's take the original problem and split it into two parts. U will be the first natural log of x, and the rest of the original problem is what we'll call dv. To fill in the integration by parts formula, we need a couple pieces. So the derivative of u is 1 over x dx. The antiderivative of dv is what we'll call v, and that is x times the natural log of x minus x. Now that we have all these pieces, we can insert them into the formula to find this integral. We'll start out with the u times v, which we've established as natural log of x times x natural log of x minus x. And then subtract the integral of v times du. So we write in for v what we had determined, and then for du, we saw that it was 1 over x times dx. A bit of simplification will happen now in this integral. This x that's in the denominator will cancel out two of those x's that would have been in the numerator had we multiplied those two together. Now we find ourselves with a greatly simplified remaining integral. And all that remains is the natural log of x minus 1. What's left for us to do is to take the antiderivative of this expression that's left. So after reestablishing the part we'd already determined, natural log of x times x natural log of x minus x, the antiderivative of natural log of x is what we've previously established, and since we have minus a negative 1, that'll become a positive, and the antiderivative of 1 is x. There are some things we could do at this point to simplify this expression, but for all intents and purposes, this problem is done as long as we add the plus c at the end.